Hello class, welcome back. Today we want to study molecules, compounds, and chemical equations. So elements and compounds. Elements combine together to form compounds. The interesting thing is that the properties of the compounds are totally different from the constituent elements from which they are formed. We'll just say, for example, the compound water. It is formed from oxygen, hydrogen, and oxygen. Those are the two elements that combine to form water. We'll just examine the properties of hydrogen and that of oxygen and the resulting compound, its property, which is water. We'll just look at that. So this is hydrogen. Hydrogen has a boiling point of minus 253 degrees Celsius. It's a gas at room temperature, and hydrogen is explosive. Oxygen, its boiling point is minus 183 degrees Celsius. It's a gas at room temperature. It's very necessary for combustion. So when you combine hydrogen and oxygen, the product is water. Well, let's see the boiling point of water. The boiling point of water is 100 degrees Celsius. And water is a liquid at room temperature. And it is used to extinguish flame. So you notice the compound which is produced from the elements, its properties are totally different from the element, the atoms or the elements from which the compound was produced. So this is just a picture. This is hydrogen combining with oxygen. You see, it's in a balloon because it's a gas. Then when they combine, they form water. This is water in a glass. It's a liquid. So how are compounds made? Compounds are made by atoms being held together by a chemical bond, by chemical bond. Chemical bonds are forces of attraction between atoms. So, are forces of attraction between atoms. The bonding attraction, it comes from the attraction between protons and electrons. That is what forms a chemical bond. It comes between protons and electrons. When they interact, a chemical bond is formed. Let's look at the types of chemical bonds. We have two main types of chemical bonds. Ionic results from the transfer of electrons between atoms and is generally formed between metal atoms and non-metal atoms. That's ionic bond. The other type, major type, is a covalent bond. Results when two atoms share their electrons. And this is generally formed between non-metals, two non-metal atoms. They bond together to form covalent bonds. Compound generally represented with a chemical formula. We normally generally represent compounds with what we call a chemical formula. or a model. That's what we use to represent compounds. So we have different types of formulas. We have molecular formula, empirical formula, and structural formula. We'll see the difference between these formulas. All chemical formulas tell what elements are in the compound. They will tell you the elements which are in the compounds. That is the symbols of the elements. They will at least tell you the elements which are in the compound. We use symbols of the elements to tell you what elements are in the compound. So let's look down here. We can see some kind of a difference between a molecular formula. This is a molecular formula. This is a structural formula. So these are just a ball stick representation. But this is the difference between a molecular formula and a structural formula. Molecular formula describe the kinds of elements present in the compound, and it tells you the number of atoms of each element present. But what does it not tell you? It does not describe how the atoms are bonded. No. And it does not describe the shape. You will not see that in a molecular formula. You will not see that. Excuse me. For example, the molecular formula of oxalic acid, this is it. This does not tell you how the atoms are linked to each other. Neither does it describe the shape. But you can see the type of element. It has carbon, hydrogen, and oxygen. And you can see the number of each element present. Carbon is 2, hydrogen is 2, oxygen is 4. That's what it tells. Empirical formula describes the kinds of elements found in the compound and is the simplest whole number ratio of the atoms. It does not describe how many of these atoms are present or the order of attachment or shape. Empirical formula will not tell you that. The formulas for ionic compounds are all empirical. And empirical formulas are derived from molecular formulas. That's why we derive empirical formulas from molecular formulas. So let's look at oxalic acid. This is oxalic acid. That's its molecular formula. It's simply a whole number ratio. It means you divide this by a number which is common to all. So you divide it by 2, 2, 2. Which gives us the empirical formula. You see that it has the simplest whole number ratio came out to be 1, 1:2. So the empirical formula is CH02. That's the empirical formula. That's the simplest whole number ratio. That's the empirical formula. So we want to look at, we've talked about molecular formula, empirical formula. Now let's look at structural formula. It describes the kind of elements found in the compound. It shows the total number of atoms in the compound. And it also shows how the atoms are attached. So a structural formula will show all that. We use lines to represent covalent bonds. A single line, we'll write it like this. That's a single bond, single covalent bond. A double bond, 2 lines. And a triple bond, 3 lines. So that is how we represent covalent bonds, lines. So this is oxalic acid. So you see, this is its structural formula. And this is its molecular formula. So that's the difference. Molecular formula will not show you the attachment, how the atoms, the atoms of the elements are attached. Then you see that in a structural formula. So find the empirical formula of each of the following. So we have aluminum oxide. First of all, this is an ionic compound. I see you cannot divide it. There's no ratio that you can use to divide. So this is its empirical formula. But let's look at arabinose sugar. You see that these numbers are a ratio of 4, so you can divide this by 5, 5, 5. So its empirical formula will be CH2O. Then let's look at pyrimidine. Pyrimidine has 1, 2, 3, 4. C4. Nitrogen, it has N2. Then hydrogen has 1, 2, 3, 4. H4. So you can divide this by 2, divide this by 2, divide this by 2. So its empirical formula is C2NH2. Then let's look at ethylene glycol. You can divide this by 2, divide this by 2, divide this by 2. So its empirical formula is CH3O. So that is how you can come up with empirical formulas. Now we want to classify elements as we want to classify substances as either elements or compounds. So atomic elements are elements that exist as single atoms. So you have sodium, argon. While molecular elements are elements that exist as multi-atom molecules. You see, we have hydrogen, we have oxygen. The molecular compounds are compounds whose particles are molecules made of only non-metals. For example, H2O, we can have HCl. We can have NH3. These are molecular compounds. You see, the elements there are non-metals. And ionic compounds are compounds whose particles are cations and anions. They don't have discrete molecules. So, for example, sodium chloride. Let's look at some molecular elements. Certain elements occur as diatomic molecules. So we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So they are diatomic molecules. Other molecular elements exist, but they are polyatomic molecules. For example, you see phosphorus, sulfur, and selenium. Those are polyatomic molecules. So just try this, practice with this. So classify each of the following as either an atomic element, molecular element, or molecular compounds or ionic compounds. First of all, this is aluminum. I'm sure should be an atomic element. It's a single atom. So what is this? You see, this is a metal and a non-metal. So metal and non-metal. Metal and non-metal are ionic. So it's a compound, but it's an ionic compound. This is chlorine. It too have two elements, atoms of the same element. So this should be a molecular element. This, you have different atoms present, so this should be a molecular compound. And this, of course, two non-metals, different molecular compound. And this is an atomic element. So these are some, this is just like some kind of practice. Make sure you do the practice at home. So atomic element, ionic compound, molecular element, molecular compound, atomic element. So now I want to look at ionic compounds. Compounds of metals that combine with non-metals and are made of ions. The metals form cations. They give up electrons and form cations. And the non-metals accept the electrons and form anions. So it's the electrostatic interaction between the cation and the anion that produces an ionic compound. It has no individual molecule units. No individual molecule units. Instead, they have three-dimensional array of cations and anions that make what we call a formula unit. So I want to see how we can write formulas of ionic compounds. We'll take that of aluminum ion and the oxide ion. Examples to write formula of ionic compounds. First of all, write the symbol of the cation and its charge. The symbol of the cation metal and its charge. So aluminum is in group 3 and the charge must be a superscript. Then step number 2. Write the symbol of the non-metal anion and its charge. Oxygen is in group 6, so its charge is -2. So switch the charge without sign for one ion to become the subscript of the other ion. So you see, this 2, you leave the charge, bring it here. This 3, bring it here. That's what we mean, subscript. So that's it. So reduce subscript to smallest whole number ratio. If there is need, there's no need here. Check that the total charge of the compound is 0. So you see, aluminum, 2 aluminum times plus 3 gives you plus 6. 3 oxygen times minus 2 gives you minus 6. So we can do the practice here. Let's see. Write the formula for the compounds made from the following ions. Potassium ion is K plus. Nitride is in group 5, so it's N 3 minus. So crisscross, take the 3, bring it here, take the 1, bring it here. So the formula is K1 and 3. But because we don't put, sorry, that's not what it's supposed to be. K3 and 1. So this is 3. But because we don't put 1, so this now leads to K3N. So that's the formula of potassium nitride. Let's look at calcium. In group, calcium is in group so calcium in group 2, 2 plus. Bromine is in group 7, Br minus. So take this one, bring it here. Take this 2, bring it here. Then calcium Br2. So this is the formula. Metal cations. Case 1. Main group metals. Main group metals, their cations have invariant charges. That is, metal whose ions can have only one possible charge. An example, group 1A, group 2A, plus some transition metals like silver, zinc, and scandium. Their ions can have only one possible charge. So these are some of the examples of cations with only one possible charge. How do we name them? Cation name plus ion. So cation name is the metal name plus ion. So that's how we name them. Case 2, metal cations. We are still on metal cations. How to name them? Transition metals. Metals with variable charges. Metals whose ions can have more than one possible charge. Determine the charge of the cation by charge on anion. So take note. How do we determine the charge on the cation? We will use the charge on the anion to determine the charge on the cation. And how do we name it? Name the metal, the name of the metal first, then after the name of the metal, in parentheses, put the Roman numeral of the charge. Put the Roman numeral of the charge after the name of the metal. So for example, this is the metal chromium. This is the ion. The charge is +2. So to name it is chromium, in parentheses, Roman numeral 2. The one with +3 charge is chromium, Roman numeral 3. See the 3? You don't write it like this. This is wrong. That's not correct. And these are the old names, but please, we are not going to use the old names, so cancel it. Don't use the old names, just for you to know, but don't use it. Naming monoatomic non-metal anions. Determine the charge from position on the periodic table. To name anions, change ending on the element's name to IDE. So you see, this is carbide from carbon. This is silicide from silicon. This is nitride from nitrogen. This is oxide from oxygen. This is fluoride from fluorine. This is phosphide from phosphorus. This is sulfide from sulfur. And this is chloride from chlorine. So we change the ending of the element's name to IDE. So it's IDE. Let's see how we can name ionic compounds. Ionic compounds are made of cations and anions. So to name ionic compounds, you have to name the name of the cation first and the name of the anion first. Generally, that's how we name ionic compounds. Name the cation first, followed by the name of the anion. So for the cation, the main group metal, just the name of the metal. Transition metal, the name of the metal, then charge in parentheses in Roman numeral. Polyatomic ion, followed, name of the polyatomic ion. So for anion, non-metal, stem of non-metal name plus IDA. So the name of the ionic compound is just the name of the cation and the name of the anion. So polyatomic ion, just name of the polyatomic ion. This is for anions. And this is for cations. So let's see how you can name binary compound. Binary compounds have only 2 elements. So binary ionic compounds have only 2 elements. And we want to name the binary ionic compounds in which we have metals and the charge is invariant. So you write the name of the cation, which is the metal, and the name of the anion, which is the name of the non-metal, the base of the non-metal plus IDA. That's how the name of the anion is. So that naming of binary compounds of metal with variable charges, name of the cation, which is the name of the metal, then charge of cation, metal, in Roman numerals, in parentheses, put the charge, plus base name of the non-metal plus IDA. So let's take an example. What is the name of CaBr2? How do we name it? Identify the cation and the anion. In this case, the cation, this is the cation, and this is the anion. First of all, identify it, you see. Metals first, non-metals first. So that's the cation and the anion. Then name the cation. The cation here is just calcium ion. The name of the anion is bromide, bromide. Then write the name of the cation first, then the name of the anion. So the name of our compound, this compound CaBr, is calcium bromide. You just combine the name of the cation and the name of the anion. So you want to practice that here. I'll do one, then you can do the other one. So the cations presents are K plus, that's the cation. And the name is potassium ion. The anion is Cl. Sorry. Anion Cl minus. This is chloride. Name of compound is potassium chloride. So that's the name of the compound. So let's try this. Cation equals to magnesium. Name is magnesium ion. Anion, we identify it as Br minus, which is bromide. Name of ionic compound So it's name of cation and name of anion. So it is magnesium bromide. So this last example, just practice and do it. So how do we determine the charge on the cation with variable charges? Number one, determine the charge on the anion first. So for example, you have this compound. The anion is S. Since it is in group 6A, its charge is -2. 2. Determine the total negative charge. So we have 3 sulfur in the formula. So total is 3 times -2, which is -6. So that's why we have -6 here. Determine the total positive charge. Since the total negative charge is -6 and the compound must be neutral, so the positive charge is +6. Then divide the total positive charge by the number of cations. Since we have 2 gold atoms, so 6 divided by 2 equals to +3. So that's why the charge is +3. So do this, then we'll take a break. So for example, this, we want to determine the anion. The anion here is chloride. And the charge is -1. We have 4. So -1 times 4 equals to -4. Positive charge. Total positive charge. Equals to +4. How many titanium atoms? Is just 1. So the charge on titanium is +4. So the name of the compound, so this is chloride, this is titanium, so name is chloride. So that's the name of the compound. Please practice on 2 and 3. So thank you so much. We'll take a break and